Linux and because Linux and Mac are Unix-based operating systems. That's why you have the advantage that you don't need to access, like to download all the steps. And why do you actually even need to use a command line or a shell? Because like before I started using a command line, I found it was really handy to just fancily use the graphical user interface and you can just click everything, which is really handy when you do single actions. But once you start doing repetitive things, let's say you have 10 files in a folder and you want to rename every single file according to a pattern, you would have to do it individually for a file. But if you start using the shell, you can actually do it in one quick command. So that's when it starts getting faster. And then imagine you have 100 files instead of 10. So a graphical user interface scales very badly. But I think the easiest way to get started is when we actually open up our shells. So I'm going to start sharing my screen now. You should all see, hopefully, a terminal on your screen. Maybe thumbs up that everyone can see a terminal in the Zoom screen. I think that looks good. And for yourself to make it easier to follow along, we posted the link. I can just repost it in the chat so you can open it, like maybe if you have two screens, it might even be easier. I'll just put it in the chat. There you can follow along with the set. Oh, sorry. I think I sent it in a private message. So everyone, sorry again. My Zoom has the odd setting that if someone sends a message to everyone, it automatically has as a default to direct message only that person. So for those on a Windows machine, if you want to open up your subsystem, you can type the search button. And if you have the Linux subsystem, you can type Ubuntu, and then it should show up and you can open it on your screen. And for those who have Git bash on the Windows machine, you can just type Git into the search and then Git bash as an app should show up and you can open it. So maybe just again checking in with thumbs up if everyone has a terminal opened. Or if someone has trouble, maybe send a message in the chat so we don't miss out on that. But it looks good when I scroll through. So first, I will give you a few cryptic commands, I would say, because we're going to be working with a specific file structure that is as a zip file. And we'll show you the beauty of a command line that you can actually download and unzip the file from the command line. And we will be working with that file structure. I'll just post the commands in the chat so you can copy them in your terminal, or if you have access to the file, to the GitHub IO link that I shared, you can also copy them yourself. And we will enter them together. So the first command is to download the file. like the command is out of the scope of this workshop, but it's just so that everyone gets started on the same level. So just copy the command in your terminal. And something there which might seem a bit odd for Windows users is when you copy and paste, you don't actually have a paste button. You just click the right side of your, like a right mouse click, paste something into the terminal, and then you click enter, and it should start downloading. And after you downloaded the zip file, you need to unzip it. You can do that using the unzip command. Some of you, when you have never used a Linux terminal before, you might get a prompt when you enter the unzip command that it says that unzip is not installed, and it prompts you to install the command with sudo apt install. So for those of you who have to do that, I will also post the command in the chat. You might be wondering what the cryptical sudo apt install means, and that's actually related to the topic of package management. And in the following weeks, Jordan will also be running a session on that. So if anyone is interested to learn more about package management and not just type in the cryptical command, and feel free to join in. So maybe just a quick check if everyone followed, and you can actually check if the command has been downloaded and also unzipped by using the first command that we learned. The first command is ls, which stands for listing, and it lists all the files that you have in your current folder. And if I press enter, now we can see that we have the shell lesson data.zip and the shell lesson data. So it would be great if everyone would type ls enter in their terminal and check if you can see the zip file, and most importantly, the unzipped file, because we need that to get started. So everyone who can see that in their own terminal, thumbs up. And if you can't, just unmute yourself or send a message in the chat, because it's really important that everyone is ready to go.
Sorry, so when you put ls, it lists like all the different files you have, but did we get to unzipping the file yet?
Unzipping was with the unzip command. So,
all right.
So the second command I posted in the chat, it was unzip and then the name of the file. So unzip and shell lesson data.zip.
Okay.
But yes, I said if you just started using, it might prompt you to install unzip first. Just let me know if it works for you, and once you're done, we can start. But yeah, I think it's super important that everyone is ready, because mainly Jordan will be working with the shell lesson data.
Sorry, I just couldn't get my computer to like copy and paste the command across. I'm just typing it in.
And yeah, Jordan as well reshared the link in the chat where you can also see them in written form, which might be easier than to copy them from the chat.
Yeah. Yeah, but a lot of yeah, that's how it's moderate.
Raina, you don't need to put the file in a certain, usually when you open the command line, let's learn our second command. If you type pwd and enter, you can see in which directory you are, and then the directory from which you use the curl minus capital O and then the link command, it automatically downloads the file to the folder you are currently in, if that makes sense. So by downloading the file with the curl command, you put it exactly in the file where you're currently located on your computer. So you should have the file if you ran the curl command.
I'm just redoing the curl command. I can't get it to paste.
Paste is in the Linux system, usually just the right mouse.
Yeah, I was trying that, but it just wouldn't go in. So I'm just typing it.
It's quite a long link to type.
Yeah.
Can I ask something? So from command prompt, it should run the Unix commands, right? If we've enabled the Linux subsystem.
Sorry?
So like if we enable the Linux subsystem, we just use command prompt to run all the commands, right?
Yeah, you can. I mean, you could also physically download the file, put it in a folder, and then access the folder through Linux.
Yeah, it's just the unzip command doesn't work for some reason. Or maybe
Does it work when you type sudo apt install unzip? Because if you just start, you have to usually install it first.
It says sudo is not recognized as an internal external command.
Which command line are you using?
Just command prompt cmd.exe.
CMD on a Windows machine?
Yeah.
And that's a Windows command prompt. That's not a Unix command prompt. And Windows is not a Unix-based system.
Right.
So
okay.
Windows has their own commands. So you can't use Windows commands in a Unix command system. So you either have to use what I'm currently using here, which is a subsystem. I think if you had seen the PDF, the welcome pack, there should be a link to download the subsystem, or alternatively, you can also use git bash, which is on the other side of my screen.
Oh yeah, I have git bash.
Then you should just use git bash for it instead, and then the commands should work.
Okay.
So yeah, maybe for everyone, it's crucial not to use the Windows command line, because Windows has different commands to Linux. Except for that, is everyone ready to go? Or does anyone still have issues? I see there has been quite a bit in the chat.
What's curl command?
Curl command is, we use it a lot for, you know, when you're on a web page and it says click here to download. So it gives you that URL and it downloads sort of like a lot of times a zip file, a .zip file. So that's what the curl command's doing. Instead of like clicking the link in the browser GUI, you can do that from the command line just by specifying the URL. So we're just directly specifying the URL. The O, the large O sort of means it's like an output. So it'll store it on wherever your current directory is in your terminal. That's where the file will download to. So is it not working at all, curl?
No, I don't know the curl command, like what to actually type.
Are you in your terminal right now, Raina?
Yeah.
Could you potentially, would you mind sharing your screen perhaps? I don't know if that's possible.
Yeah, I was thinking the same.
All right, so on your command line, are you typing in?
And I can stop sharing.
Space dash capital O space and then the URL.
I don't even know how to copy and paste into it.
That's all right. That's all right.
You paste with the right mouse click, or if you have a touchpad, just the right top bottom corner.
Okay, cool. So there's your screen. So in the chat, I will paste the command again for you. Oh, yes. So if you go into the Zoom chat, you should see the curl command there.
Yeah.
Zoom chat, and then can you copy that?
Just do a right click now. If you have a mouse, it should be the right.
Or Control V or something? Is it Windows?
When I do Control V, it does that.
No, it's a Linux subsystem, so the Windows like Control V, Control C doesn't work.
Well, I'm right clicking. It's not doing anything.
Shift insert might work. Shift insert.
Shift.
No, sorry.
Or Control Shift V.
That's all right. We won't have to copy and paste many commands. It's just we thought
It's
copy
the
paste.
only one actually.
It might.
Oh,
Might
I'm
just
gonna have to type it.
Yeah, you might just have to type it just for this one because the rest of the tutorial we're going to be typing anyway. So it's
And
just
most commands will be very short as well.
just because the URL was a bit longer.
Yeah, we thought to make it convenient for you guys by just copy and pasting it, but it doesn't seem to have worked 100%.
Just let us know when that's finished, Raina, if it worked for you.
It might be with the chat. I find that if you click on the text and copy, it doesn't copy. You need to click on the 3 dots right next to it and select your copy and then paste. Otherwise, it won't copy what's in the chat.
I think it's a paste issue at this point in their terminal. I think it's copied.
Mm-hmm. I do have a question while she's working that out. If
Sure.
it worked fine on mine, but if for some reason I couldn't do the command, how would I access the file from the folders? Because if you can tell us, it shows a file or the folders, but I don't know how to access them.
Do you have a Windows machine or a Mac?
I'm using a Mac at the moment, yeah.
I think in a Mac, you should automatically be able to access your file system. Correct me if I'm wrong, Jordan, you have a Mac yourself?
Yes, absolutely, yes.
On a Windows, it's a bit more complicated, and we will learn because you have to mount your file system, but I will show you how to do that.
Mm-hmm.
But yeah, you can access every file you have on your machine. You just have to navigate to the right folder, and I will show you how to navigate to the folder in a bit.
Okay, thank you.
How you going there, Raina? Were you able to type in the
Think
command?
so?
Were you able to type in the command?
Yeah, it did something.
Okay, cool. And then type in ls, enter, and see if it's downloaded.
Yeah, if you type ls, you should see the shell lesson data.zip file.
Yeah, it showed up in red.
Great.
Great.
Okay.
And now
Thank you.
try to type the unzip command, because I saw when you shared your screen earlier that you already did the sudo apt install. And after you unzipped it, type ls enter again, and then you should see the shell lesson data in blue.
Yeah.
But that's just for, I think the colors are just default for the Ubuntu subsystem. So if you have different, like on a Mac, it looks different.
Yeah. All right.
So,
Yeah, I think it's worked.
great. So everyone's ready to go. So while troubleshooting, we already learned about 2 commands. And in this section, so if you go one step further in the files that you have open to the navigating files and directories section, so it might help you to follow along. And we already learned about 2 commands while troubleshooting. The first was to check in which folder Raina is, and we did that by typing pwd and enter, and then it prints the directory we're in. And the directory might be different depending on your machine. Like this is a Linux subsystem, so it has the Linux structure. So you will see it has a home and then my username, and the first slash there is actually the root directory. And you will see if I open my Windows terminal, like the Git bash terminal, which is not a Linux subsystem, but just accesses my Windows system, and I type pwd, enter, that you see my regular C users and my name. Because a Windows machine doesn't have the root directory. And the next command that we used to check if the files are actually in the folder was the ls command. And the ls command makes a listing of all the files in the current directory. And it's also interesting to type ls space -a or dash, and the dash is called a flag. A flag, you could call it, it accesses subcommands. Like list is one basic command, but you can then have a variety of specific ways you want to list your data. And depending on how exactly you want to have your data listed, you can specify that with the flag. And -a means that you list all commands, so also hidden folders. And if we type enter, you can see that there's quite a bit. Most of the files with the dot before are configuration files, and we can ignore them for now. The two interesting ones are the single dot and the double dot. Those files will be used to navigate through the file system. A single dot means current directory. That's why all the configuration files also have a dot before them, because they are located in the current directory. And double dot means previous directory. So this double dot that is located in our current directory refers to the parent directory. So we check that we are in the folder mnsphere, or for you, whatever your username is. And then the double dot refers to the directory one folders up. So it would refer to the home directory for me. And those commands are really handy when you start actually navigating through your files. For instance, when you want to go one directory back, you can type cd, which stands for change directory, and then space and 2 dots. And then you press enter. And now you can see that we are in the home directory. If we type pwd, we can confirm that, because we access this double dot that we're referring to the home directory. Now we would like to go back in the user directory. So my users. So how do we do that? We type cd again, then slash, and then then the name of our user. So for me, mnsphere. And the good thing is with Unix, I don't actually have to type it. If I type mn and press tab, it autofills. And if we double check with pwd, our directory, you can see I am back in my user directory. Another handy command connected to cd is cd dash. If you type cd space dash, and you go back to the directory you were in before. So we were in the home directory before. So if I type that, I go back in the home directory. And if I type it again, I go back into my user directory. So if you're working with two different directories and you want to jump back and forth between those directories, it is really handy for you to just use that command instead of typing cd and then the path of the directory you want to go to, but you can just use cd dash. Also, something interesting is, as I mentioned, ls has a lot of different flags. If you don't have to remember all those flags, but the advantage of Linux is you can check on every command by typing man and then the name of the command, man ls. Here, for those of you who are using git bash, you should type instead the name of the command and then double flag help, because the man command doesn't work on git bash. If we type man ls, you'll see it's a kind of bit of an explanation that man lists directory contents, and then it explains all the different flags. So if you're ever unsure about a command, you don't need to remember it, but you can just check on it. So with those three commands, you can navigate through your file structure using cd/2 dots to go back, or cd/ the name of the file to move one directory further. And you can use pwd to check where you are, and ls to list files. A quick detour, because you guys mentioned before to access your own files. If you go back, for those who have a Linux subsystem, so the Ubuntu one, if you go back to your root directory, so 2 times back until you're in the root, you will see the directory mnt, which stands for mount. If we access mnt, we'll be in the mount directory. And then if I use the list command, ls, to print, you can see that now I can access my C and D drive of my Windows machines. So if I would go into my C drive and I would print it, I would see all my Windows stuff. And this is how you can access all your data saved on your Windows machine. One last handy trick here, if you want to go back to your home directory, we don't have to navigate all the way back, but the shortcut is to simply type cd. And if we check, we're back in the home directory. Maybe just a quick checkup here if everyone has been following up on the cd, ls, and pwd commands. Maybe just a thumbs up, or if there are any questions as well, feel free to ask them before I move to the next section.
Yeah, I just use the man ls. How do I go back?
Q. Sorry for quit.
Oh, excellent. Thank you.
Great. Anything else, or should I maybe elaborate or something, or are the commands clear? So I think those are like the most basic commands which you need to navigate through your file structure.
I'm sorry, I'm still a bit confused on what's with Mac and what's with the Linux subsystem, because I've tried to do the CD stuff with Mac, it didn't work. So I'm assuming it's for the Linux subsystem?
No, it should work with a Mac as well.
Strange. CD should work on Mac.
All the commands should work on Mac and Windows. The only thing is that on a Mac, you can access your normal files from the start, and on Windows, you have to go into the mount directory first. That's the only difference.
What's the CD command you're using, Jules?
Well, I tried just CD, and I tried the going back to the main folder, the CD ... and none of them worked. The pwd command worked fine, and manual.
Did you do cd space ... You need to put a space between the CD and the 2 dots.
Oh, there you go. Okay.
Did it work?
No. Thank you.
Great.
I wasn't sure if you're talking about one or the other, both of them, because it wasn't working. That's what it was. Space.
Right.
Thank you.
Great, so it worked now. Anyone else had any problems with the 3 commands? Or maybe I should repeat something, or are you all good to go?
I got logged out for a little bit, so I've just come back. Were we just using CD and LS?
Yeah, to navigate the
PWD?
file structure. Yes,
Yeah, that's
those
fine. I'm
3
fine with
commands.
those ones. Yeah, no problem.
Okay, great. So now the next step is after you navigate through your files, to also create files. So the next commands we're going to be learning is how to manipulate your file structure by copying files or creating new files. So first of all, now we will access the shell lesson data, which we downloaded beforehand. Maybe for that, because we did quite a lot of stuff here and we're starting a new session, which is, by the way, on the next side. When you open when you have the manual open. And to clear your window, you can actually type the command clear and enter. And now all the stuff we did before is vanished and you can clear it. And one other thing that I remember, which might help you if you want to recap what we did in this session, all our commands. If you use the arrow that goes up on your keyboard, you can see it's like a memory of all the commands that we have used. So this might be good if you don't remember a command and you want to try it again. You can just check all the commands we used during the training. So now we want to access the shell lesson data. So we use the cd command that we just learned, cd, then space, and then shell lesson data. And we can again let it autofill with the tab, so we don't have to type it, and enter. And we can use the list command again to look what is in the directory. So you can see there are a few files and a few directories. And if we want to create a new file, we type the mkdir command, which stands for make directory, and then space, and then we type the name of the directory that we want to create. Let's call it here phases, and enter. And when we then double check again with ls, we can see that now we have a file, created a file called phases, just by using the mkdir command. Make directory can in that way only be used to create one directory, but if you want to create a whole path of a few nested directories, you have to use make directory and then a flag again, P, and then we could create the directory project/results/best. And we would see if we type ls that now we have our project here. And if we access project with cd/project again and do ls, we can see our results. So with one command using the make directory space flag p, we created a sequence of directories that are nested. Now the next step after we created a directory is to create a file. In this session, we will be using the basic text editor called Nano, and you can create a new file typing nano space and then the name. Let's call it test.txt and type enter. And you can see that you are in the text editor now. Let's say this is a new file. And you write first, after you wrote your text, you have to write to the file. You do that by typing command and then O. and then you tap enter, and then you have written, so kind of saved what you wrote, and then you can exit it by typing Command X. And the good thing is, as you can see here at the bottom, you can see all the commands. That's the beauty of the Nano text editor. So now Control and X, and we have exited it. And you can always print a file to screen using the cat command. So if we use cat.txt, you can see it's actually now written to the file. Could everyone follow so far of creating files and making directories? Maybe just give a thumbs up, or otherwise ask a question, raise a hand, write it in the chat. I'm trying to keep an eye on the chat, but I think Jordan is doing a good job with that. So the two commands are mkdir to create a directory, and if you yes, Aiden, we're using Nano because it's easier. Personally, I think Jordan and I both also use Vim, just because you can do much more with Vim. So if you know Vim, definitely feel free to use it. But I think if you just start with it, that the commands are listed is actually the main reason. So I think everyone is fine with those two commands. Then the next one would be to how do you rename a file? Let's say the beauty of Unix is that you're using the move command to move a file and to rename a file. Because if I want to rename the file, I would type mv for move space test.txt. And then let's say we want to rename the file to test1. So I would type test1.txt and enter. And then I would check ls, and we would see that we renamed the file, because the logic of Linux is that they moved test.txt to the new file called test1.txt. And that's how you can rename a file. But you cannot only use move to rename a file, you can also use it to actually move a file to a new folder. Let's say we want to move test1.txt to the results folder. So we could just type test1.txt. Sorry, I'll just clear my screen to make. You could type move and then test1.txt and then results. And now we can see the file has vanished if we use the list command. And if we use, again, cd, as we learned to access the new folder, cd space results. And then we use the list command, we can see that now we have test1.txt in this folder. If it's getting too many commands, feel free to tell me to go slower or to interrupt. But otherwise, I think it might also be good for you to just catch up when you go through the manual and have another look at the all the commands, because I think it might get a bit confusing. And maybe just a thumbs up if everyone is still able to follow. Looks good, I think, when I'm scrolling through the chat. So the next command is the copy command. So if with the move command, we saw if you move a file, it actually disappears from the original location. But sometimes you just want to copy a file, so you want to keep it on the original location and move it. I just see a question on how do you move something to the current directory? move results txt, and then what do you mean with the current directory? You have, like, if you are in a directory, like, you can always access your current directory, or if you want to access, like for us, the standard directory would be the home directory. You can access the current directory usually with a dot. So if you want to move something to a current directory, you can use a dot. Or what Jordan wrote as well, results test1.txt to test1.txt. You can also run it. Sorry, my command line is not responding. So I think in your question, Aiden, you were in a not in a directory results, but in another one, right? Oh, okay, sorry. But I think with the command in the chat, your question is sorted, right? Sorry, multitasking is not always my strength. So the next command would be the copy command. So you would copy a file. So let's say we want to copy test1.txt, all the content into test2.txt. So you would use cp and then space, and then test1.txt, and then you type test2.txt. And if we then use the list, we can see we have both files. And if we use cat to print the content of test2.txt, we can see it's the same content as what we had in test1.txt. And if you want to copy a whole file, you use the command cp space my flag R, because, and if you then type the file, the name of the file folder, you can recursively copy every file that is in the folder. So every time you're doing a command, usually for a folder, you use flag R to do it recursively for every file in a directory. And the last command of file manipulation is that you want to remove a file. Let's say we have test1.txt and we want to delete it. We would type remove rm space and then test1.txt. And then if we do a listing, we can see that test1 has vanished and we only have test2.txt in the folder. And if we want to delete a whole folder, let's say the best folder, you can't just use the remove command, but you have to do it same as with the copy to do it recursively. So you would have to type remove and then minus -r and then let's say best for the best folder, and it would be removed recursively. However, removing files is dangerous in Unix because you don't have a trash bin as you have in a Windows system. But if something is removed, it is actually removed for good. So often you want to use remove dash recursively I or just I, which means you do it in an interactive way. And then for every single file in the folder, if you do RI, you have to double check with yes that you actually want to delete the file. So maybe double checking if everyone is okay with the copy and the remove commands. So now we have created directories, created files, moved directories and files, copied them and removed them. So like file manipulation. RMR is best for if you want to delete a whole directory. Like for instance, when you're having a backup or when you're playing around with something just to test something and you want to remove a whole directory that has a few files in it, but you don't need anything that is stored in the directory, then you can use remove flag R. because if you type remove and the name of a directory, Linux will prompt you with an error message and will be, I can't remove the name of the folder because it is a directory. But yeah, whenever you want to remove a whole directory. And the last thing that you guys will need for the session with Jordan is wildcards. So now we were always precisely typing what we want to do. But let's say we want to, let's go one directory back to project. Let's say we want to work with a few files. And I will show you another way to create files, because with Nano, you saw it automatically opened a file. Well, let's now just create a few empty files called test.txt, test1.txt, test2.txt. And you can create all those empty files with the touch command. If now we do a list again, you can see that now we have created 3 files. And now we want to move all those 3 files to the results folder. So we could either type all the names of the files, or we can just use a wildcard, which is a star here. And we can type move everything that is a star and has an end in .txt. So it doesn't matter what is before .txt. That's what the wildcard states, but it only matters that the ending .txt is included. And then we move that to results. Oops, I forgot a slash, sorry. Space, obviously. Now we can see all the files have vanished. And if we access the results folder, we can see that all the 3 files have been moved to results by just using one wildcard command. I think I will leave it here. There's another wildcard, which is a question mark, but I will leave it here because to avoid that we go over time, and I will pass on to Jordan. And maybe just to double check if everyone is comfortable with the copy command, the make directory, moving and removing, or if there are any questions. I also prepared a quick Kahoot session. I'm not sure if anyone is keen with a few questions about that topic, but it might be, I think we might be a bit low on time. I don't know, what do you think, Jordan?
Maybe we can circle back to that at the end if there's time.
Yeah, it's just to double check your understanding and have a bit of a competition feeling. But otherwise, I will pass on to you.
Okay, that sounds fun. So this is going to be hard to match up to the Kahoot thing, but we'll see how we go. All right, I will share my screen and we will be moving on to section 4, which is the pipes and filters. Okay. All right, thumbs up if everybody could see my screen right now. All right, so go to my terminal window. Just going to make my terminal window a bit smaller. Is the writing size in the terminal window too small, or can everybody see that? If somebody could speak up if it's too small, that would be ideal.
It's fine for me, and I see that in the chat it's also fine.
Okay, great. Okay, so first we're going to CD into our shell lesson data, just so we're going to start fresh. I'm not sure what directory everybody's in right now, so I'm typing in CD, and then I am doing the symbols for the home directory in bash, followed by the lesson data directory that we downloaded. I'll do ls, which we've talked about listing, and specify the directory name molecules, So we can see all the contents of the molecules directory. I'll just confirm the path to the current directory, so present working directory command. You can see we're in my home directory, user Jordan Makins, and then the directory that we're currently in there. Now I'll cd into molecules as per the training written instructions. So we're now in the molecules directory, and we can confirm this with pwd. One command I use a lot is as I type away and my terminal begins to fill up with white text, I like to clear it every now and then. Clear kind of resets the presentation of the terminal. It doesn't affect the directory or anything, any of the files or anything like that. So it's just a nice little housekeeping thing. The next command we're going to run is word count. L, so lines, and then we're going to specify a wildcard, and we'll get into that. So the file type is .pdb here, and the wildcard is basically saying, or asterisk is basically saying, it doesn't matter what the predecessing name is to the file name, to the file type. We'll get all the different types of names .pdb files, and we will count the number of lines from those. So as you can see, we've got cubane.pdb, 20 lines in that one, and so on and so forth. Across these 6 files, we've got 107 lines total. This could be really useful if you've just downloaded a large number of data files and you're trying to find how many rows are present in a data file. It's a really quick way to do it, especially across a population of files. And you can see the use of this if you were to do it over a directory. So it's a really quick way to finding data sizes, I guess, in terms of the number of rows. Some troubleshooting. So if I were to try to do the similar command, but forget to specify the files of interest, and I just typed in WCL, my terminal hangs. It basically isn't sure what I'm trying to get it to do, and it will not reset until on my Mac, I'm going to press Control-C, which will cancel that command, even though it was sort of running or hanging there. And now I can reattempt that, and I would do something like the previous command, word count, number of lines. If we want more information about word count, we can type in man word count, and we can get some information here. So word, line, character, and byte count. The specific arguments here. So the number of bytes in each file, the number of lines in each file. So man on Mac, I think the other one is something like --help is if man doesn't work for you on your platform, try that one. I know help doesn't work for me on the Mac. So I am using man. There is another one, which I will get to at the end of my tutorial that I actually prefer over man, which I won't mention yet. So if we're moving down on the section 4 tutorial, we will do word count, and we're basically going to store the output from this command into a given file that we decide to call lengths.txt. So now we're not getting any response on our terminal like we previously did up here. Instead, this response should be stored in a file called lengths.txt. So if I go listing, I should be able to see that new file there. And if I cat the lengths.txt, and I'm sure you've seen the tab instruction. So basically the tab instruction is you're typing something, you want to autofill it in your terminal because the computer already knows lengths.txt is in that folder. You hit tab and it'll auto complete that, that command for you. So there we go. We can see the contents of the lengths.txt file with the command cat there. I'm going to clear my window. If anybody's having any issues with any of things I've said, please post in the chat or vocalize, and please feel free to interrupt me. I will try help and troubleshoot as we go. So now we're going to move on to the sort command. So if we look at sort, we can see that we're going to sort records or lines of text and binary files. And we can see we've got a variety of arguments that we can specify. So we will attempt some of those. To get out of man, just a refresher, I type in double capital Z there, and I'm instantly out of man. So we will run. If you look at section 4, at this part here, where we get past the cat lengths, we have a sort of quizzy type question here. What does sort n do? So we're going to look at this file here, shell lesson data numbers.txt, which contains the following lines. If we run sort on the file, the output is relatively unchanged. It doesn't really look like it's got a numerical sort. So in order to specify that numerical sort, we can run the option n, followed by the file name, of course. So we will do that in the terminal. And see for ourselves. So just looking at our working directory right now, we're currently in molecules. So we will get back to the lesson data, shell lesson data directory by specifying cd space .. And you can see we're in there now. So we will go sort n numbers.txt, and we will see the contents of those have been sorted in ascending order by specifying the numerical. If we were just to do sort, we can see it's not really sorted numerically at all. So one thing with that, the default for sort is alphabetical sort. Hence why we need to specify n as our option when we use sort for numerical data. And just moving down, so we've got, just looking at the contents here, and we're going to go back into molecules, or actually, I think our molecules contains, so if we cd molecules, I think our molecules contains our lengths.txt. So we can try move that file, and we'll try move that back into the subdirectory. So I'm going to specify dot, which is basically, this is saying the file in our previous directory. I hope this works. And we'll try that. So lengths is in our current directory, molecules, and we want to move it to the previous directory or the parent directory behind molecules, which is the shell lesson data. So that's the idea of this command. Now we will go back to our shell lesson data, type in listing, and nope, that did not work as nicely or play as nicely as I was hoping. CD back into molecules. Lengths is still there, so it did not remove it. So I believe that, so if we type in move lengths, that this one should work. So the double dot is for the previous directory, hopefully. Type in list, you should see it's moved there. And then if we go back to the shell lesson data directory, we should see lengths there now. So in that parent directory there. That was a lot very quickly. So I hope everybody's on the same page. If you weren't able to follow along there, please message and we will try to get you on the same page. I'll give everybody a few seconds just to cool off. That was a lot of quick typing. So if anybody is stuck or wasn't able to get to where we're at, please speak up, and that's okay. Okay, so we should be in the shell lesson data directory now.
Sorry, I've got a small issue.
Sure.
So within the molecules folder, I've only got the files ending in .pdb.
Okay, sure. Let's see.
So I've obviously done something incorrect.
I wouldn't worry about that too much. Perhaps these are previous files that I have developed in my own time on my own PC. So I would ignore that and just assume that the .pdb is all that you need.
Okay.
Yeah, by default, you only have the PDB files. I just checked it.
Okay, great. So yes,
Okay.
thank you.
You're correct.
Thanks for raising that. Good.
Cheers. Cool.
No worries. I'm going to clear that. Is everybody okay for me to clear that? Maybe I'll just leave it for now in case anybody wants to follow any of these previous commands for the near term. So now we can run sort n lengths.txt. And basically what I'm trying to emphasize here is that it's really bad practice to redirect to an existing file. So as we saw previously, when we saved our initial data into lengths.txt, that was the lengths of the .pdp files by wc space -l wildcard.pdb. When we stored that, into lengths.txt, we used this redirect or storage arrow pointer. And now we are running a command where we're sorting the lengths.txt file, but we're reassigning that or restoring that in the lengths.txt. This can often corrupt the file, which is really bad because it becomes very difficult to recover that. So I just want to point out that in the future, when you work on your projects, be very careful about redirecting a command or the output from a command into an existing file like this. Okay, so I'm going to run that. This should be in line with the section redirecting to the same file equals bad in section 4. And if we look at lengths, it may very well be corrupted. Yes, so there's no content. I can go to nano, inspect, there's nothing there. So now I'm going to exit out of nano if you joined me there. If not, don't worry about it. Back to the platform. The echo command. So echo command. Echo is basically very similar to print from Python. If you're familiar with print from Python, we can take a look with man really quickly. So it writes arguments to the standard output, which is a sort of convoluted way of saying it basically prints whatever you tell it to say, or it tells, yes, it prints whatever you tell it to say. So if we say echo hello world, the common example, the output, the standard output is going to contain the text or string hello world. We can do something a bit more complex as per the tutorial, where we're actually echoing a line of text that contains echo itself. A little bit confusing, but we will see what happens. The best way, often the best way to see what happens. I mean, you got to be careful when you're removing files or overwriting data, but with simple commands like, or not simple, with commands like echo, where the potential to ruin your data is significantly less than, say, something where you're redirecting a file or removing a file, it's good to experiment by practice. So we can see the echo, even with echo inside the text here, is simply just going to print out the echo command prints text, which is all this that follows the echo command. It would be the same in Python if you remember, if anybody here has used Python, it would be something like this. But we will not execute that. That's just for our Python developers out there, given Python's popularity in the coding world. We can store the output from echo, and we're going to see how to append data to a file with the command line. So here I've got echo hello, and then I'm storing the output from this into a file which I'm creating called testfile01.txt. I'm going to hit enter. I can cat this to see the output. So I went fast there, but basically I just started typing this and press tab. And we'll see hello is now stored in that file. You don't have to do the nano entry, but I will just show you as well in nano that it's now stored in our text editor there. So I'm going to exit out if you're in there. Okay, so if we're following along in the written text, doesn't matter if you are, the terminal's the main important usage here. We're sort of up to this section. What does this double greater than sign sort of pointer mean? So we are currently here for those following the written text. So we can type in echo hello, and this is append file 02. File 02, okay. Cat test. Now you see if I start typing in test and I hit tab, it stops at the sort of common shared ground between the two files we've created here. So how you can overcome that is you simply type in the next unique identifier here. So these obviously these are shared naming standards, and then we have 1.txt, whereas this is 2.txt. So we can type in our 2 there and then hit tab again, and it'll finish the file completion for us. Just helps us code that little bit faster. And we can see hello is printed there now. But to really see the power of the append, we can rerun this command, which will, so you can either, depending on your preference here, you can either retype this, or we can push the up arrow on our keyboard, which will take us to previous commands. Press up again, takes us to the second most previous command, and so on and so forth to the nth command. So I'm going to now press enter there. I'm going to do the same thing again now. Press up. You'll see that was the most recent command I did. Press up again. I want to cat now to see what has changed in the file. So cat, and that's basically what append does. So it's now put at the bottom of the file, a new line of hello to the existing previous hello. And we could repeat that. So I'm going to, you don't have to do this last step I'm going to do now. I press up twice with my arrow key. I'm going to append a third time just to really drill home the use of append. Press up again till I get to cat and press enter, and now I have 3. So it's a really quick and effective way to add new data into your existing files. So that's how you can combine echo with the append to an existing file. I really want to remind everyone that this is significantly different to the single save or store to file command. So I'll probably, you know what I'll do, we might need this later in the tutorial. So just to be safe, I'm going to create a test file 3 copy. So I'm copying the test file 2 to a test file 3. I'm going to hit enter, and I'm going to repeat this, but instead of using append, I'm going to do that single storage line just to really drill home how important it is to know the difference between the two. Echo hello test file 03.txt. And now when I go to look at test file 3.txt, which should have been a copy, it's overwritten and it hasn't corrupted, but that's still not ideal. We really want to be in control when we're messing around with data files. So it's best practice to avoid using the redirect of the output from the standard output of this command, redirecting that to an existing file. It's best practice to completely not do that. I highly recommend. Okay, we're going to move on to the latter part of our pipes and filters tutorial. So I'm going to look at list, typed in the list command here. We can see all these test files that we've created. And we want to be, if you look at the tutorial, we want to be in the data folder. So we're going to look at, we might do this section here without the command line. So we've already met the head command line and tail, which prints the end of a file. But now we want to consider how these are going to affect when we store or append data. So does anybody have an inkling or an idea of how these two commands would affect the animal's text file to which is this command is then output to the animal subset.txt. This command then takes sorry, my computer's frozen a second, just give me a moment. This then takes the tail of the animal.txt and appends to animal subset.txt. So from options 1, 2, 3, and 4, we'll maybe take 30 seconds. If somebody wants to type in the chat what they think the solution is, that would be, we'll see what people can come up with. And I'll just show everybody what the animals.txt file looks like. So I'm still in the shell lesson data directory here. I type in cat, the nested directory here, data animals.txt. That's the path from the current directory to get to animals.txt. And you'll see the contents of that file, the animals.txt file there. So I'll just walk everybody through now. I'll check the chat. Melissa, have we got anything in the chat?
I think I have been monitoring it so far and hopefully answered all the questions.
Okay,
Maybe Caleb, just check out if the command I wrote you answers your question. But yeah, I think we should be good with the chat.
Would you like me to check the chat? Or you think it's all good to keep moving?
Should be all good. You got some answers, I think, for your question, like 3, and then first 10 lines into file, then append last 10 lines. I think those were the answers for the question you asked.
Okay, great. So for this question, head N3 is going to take the first 3 lines of the animals.txt, save it to a file called animals_subset.txt. Following that, it'll take the last 2 lines from animals.txt. So N2 specifying last 2 lines using the tail, head N3 specifying the top 3 lines or the uppermost 3 rows from the animals.txt. So you basically should have the first 3 lines and the last 2 lines of the text. So option 3 is correct here. Okay, piping. This is kind of what we've been building up to by looking at our storing our outputs from our commands into files. Now we're going to look at a way that works in a similar fashion, but basically you continue a chain where one output from a command gets fed in as input to a new command. And you can put these things called pipes, which is signifying to your terminal that we want the output from this command to form the input for the next command. So we will see this in action as we go. It's best to see it by doing. So we will try this. So just going to check we have our lengths.txt file with listing, because that's the file we're going to be sorting here. So we will sort first, cat lengths.txt, and it's corrupted from that previous exercise we did. So we can quickly start that again by just simply removing lengths.txt, and then we'll recreate it as we did earlier on in the tutorial. So I've just removed it, so I shouldn't see lengths.txt here. And then I can word count lines wildcard.pdb, but that is in the molecules directory, I believe. So here I am word counting the number of lines in the molecules directory files that contain .pdb, any file name before the extension is fine. And we will save that to lengths.txt. So we should have an uncorrupted normal lengths.txt file. Depending on if you did it this way that I've just displayed, or whether you have the original we did earlier, you may or may not have this molecules path here, but that's fine. It's not going to affect what we're going to do here. So we will type in now sort n lengths, whoops, shouldn't be a space there, lengths.txt pipe. So we're going to transfer the output from this, or as the input, to head n1. So just logically following or trying to make sense of this as we try problem solve, sort n lengths, and then we're going to take the first line from whatever happens from this. So we'll do that, and we will see that that produces this line, or you may get it without the molecules, depending on what your lengths.txt file looks like. And as you can see, that's very similar, much the same to what we expect from the output here. What's it doing exactly? So sorting this lengths.txt file, we have our lines, the number of lines associated to each file, and it's numerically sorting it in ascending order, so 9, 12, 15, 20, etc. And then we're grabbing the top line from that output, which gives us 9. So I hope that's clear to everyone. If it's not, please feel free to interrupt or post in the chat. We'll move on to the example involving three lines. So for this one, I think we need to cd into molecules. So cd into molecules with me, just going to double check the path that we have here. Run this command, wcl, so number of lines in the .pdb files. Send that across to sort, the output of this command, to the sort using pipes. And then the output of this entirety, we will pipe to head n1. And that should give us this output, which should be the same, which is the same as the tutorial documentation. So what's happening here is we are basically creating the lengths.txt file from scratch here, sending the output of that to the sort, numerically sorting, and then grabbing the first line there. So this is kind of doing the whole, this is essentially doing the same thing as this command here, because we In this command, we already have the lengths.txt file, but here we're doing everything from scratch with all the .pdb files. Just to visualizing is often a good way to support what we're learning. Excuse my silly little Pinterest saving thing there. Yes, I use Pinterest. The workflow, as you can see here, the initial command, the output from that flows on in the shell, and then we can either store that in an output file, lengths.txt, or with our pipes, the output gets used as the input for sort n, the output from the sort n gets used as the input for head n, and that gets output to our shell. So just a nice little quick visualization way of looking at that. All right, quiz time. In our current directory, we want to find 3 files which have the least number of lines. So let's say we're doing a machine, this might be something to do with machine learning. We're doing testing, training, and validation data split, and we're trying to get a validation data split. It's maybe time series, so it's maybe time related, and we're trying to get the smallest amount of data for maybe the validation set or something like that. So we want to find 3 files which have the least number of lines. Which command listed below would work? So if you could post in the chat what you think is the potential solution here for finding the 3 files that have the least number of lines from these 4 commands. Please do that now. I'll give you roughly 30 seconds and then we'll move on. So just as we think of this, we know that sort n sorts by numerically ascending. So it starts with the smallest at the top of the file and goes to the largest number at the bottom for its output. So we'd either want to combine the sort n with a head type command, which all of these do. We wouldn't per se want to do head before sort, because sort will give us the numbers in an ascending order, and then we will want to grab the top 3. So that eliminates this one. Here we've got, we're not using pipes, so this is thinking we're wanting to store it into a file name sort line n, which is going to give us some weird error in the command line. So that basically process of elimination gives us down to these 2 commands. As we've shown in the tutorial, we use that sort of single number specified for the number of lines that we're after. This 1 to 3 doesn't look like the language we've been using on the command line. So I would be persuaded to follow this one, where we are getting the word counts or the line counts from any number of given files in the current directory, which is what the wildcard's saying. So it doesn't matter what the naming convention is in our current directory and all the nested directories. We're going to grab all those files. We're going to sort those by their line counts in ascending order, which is the default, and then we'll grab the top 3. So it should be 4. And that's what we can see. So I hope that made sense to everyone. If it didn't, please comment. And this will be an interesting one here, mostly due to the fact that we're now using R, which is a way of saying reverse. So if you could think of how we've done sort -n, if we were to combine that, I'll show you on the command line, sort n, but put the R argument in addition, and do that with our .pdbs. We should now, instead of getting the default ascending, we should get it in not ascending anymore, but descending order. So from the largest number down to the smallest. Oops, that's that's not what we wanted. Excuse me. Lengths.txt, my apologies. There we are. So our total, then 30, 21, 20, 107, 12, 9, etc. Okay, moving on. We've talked a little bit about, have we talked about cut yet? I can't remember if that was specified, Melissa. The cut command.
It was, I think, in the initial learning, and it might be useful to know. Like, I think it's good to refer to it quickly.
Cut is good. This is a really powerful command. So I'm going to CD and make sure I'm in this shell lesson data, pwd. Then I'm going to go into the data folder, CD into data. Should be in data now. And if you're following on the section 4, we're up to this pipe construction section. So now I'll type in cut d, comma, f to animals.txt. Give everybody a few seconds to catch up. So what does cut mean? Here we're specifying the D argument, which is delimiter. If you know, like a lot of Excel files are comma separated, or .csv files, so the columns are separated by commas. So you'll have one column, comma, second column, comma, third column. So this is basically telling us separate the file based on the comma. And then we're looking for the second column. So we can sort of affirm the output here by typing in and seeing what the contents of animals is. So cat animals, we can see we've got column 1 here, comma, column 2. And what cut does, it basically cuts the second column, as we've specified here, from the data, the initial data, the original data file. So it's a really effective way of separating information, and you might get into situations where you need to only use a certain column, extract a certain column, maybe save. If I type up on my key twice, on my arrow key, I might want to save the first column as a dates.txt file, for example. And then I should have all the dates saved here. And you could probably go even further and split on the dash delimiter here and get year, depending on whether this is American or Australian month convention, month or day. Looks like it could be day, but anyway, we won't focus on that. Moving on. So we're going to finish up this section because we've still got one more section to go through. So we talked briefly about the removing files. So I'm not going to go too much more into that, but this is using wildcards for specifying the file name. So we can remove, maybe we're interested in removing all TXT files in our current directory because we were using TXT files as some sort of testing experimental type setup, and now we don't need them anymore. We want to clean up our data directory because we're handing over the project to a potential client, or we're handing the project over to our supervisor at the end of the year, and we want to get rid of all these unnecessary files that we have in our storage system. So we can specify, let's make up a file touch test.csv, touch test2.csv, and we want to remove all CSV files from our directory. So now we should be able to see that they don't exist. We created them. Touch creates a file. So we created 2 CSV files. and we're simulating removing those CSV files from our directory to clean it up so that when we hand this over at the end of the project, they're all clean. So the key points from this one, WC counts lines, words, characters, inputs. Cat displays the contents of a file. Sort, you can sort a file with the sort function. Head displays the upper lines, which you specify with the N argument. Tail is the opposite, it does the bottom lines of a file. We can save the outputs from a command into a file using this symbol. We can append to a file, and it always goes to the bottom of a file using the double greater less than type looking thing, but we prefer to think of this as an arrow pointer sending output to the file here. And then a pipe is specified with the vertical line. We have our first command, second command, and the output from the first command gets piped or used as the input for the second command, and so on. And you can do this n number of times. All right, so we will now move on we'll click back onto the Pawsey-Intern training here. We're going to skip loops and scripts. If you do have excess time or extra time available this week, I do recommend exploring these two sections in the order of loops and then shell scripts. If you've written or have some experience with Python coding, you should be a little, or potentially will be a little bit familiar with what a Python script is. And this is just the bash equivalent of doing that. So we're going to go to section 7, finding things, to finish up this tutorial for today. So finding things, how can we find files? So if we're looking for a specific file with certain information, if it contains a certain data point and we've lost track of it, maybe we're 3 months down the line of a project and we collected some data a long time ago and we've forgotten where it is on our file, how do we find that type of information without using Explorer? And once we found the data or the files, how can we replace and edit them quickly in the command line? So we're going to introduce grep, find, and sed for this purpose. So we're going to start out. I'll put the terminal back up. We may as well start with a clean slate as well, given we're in a new section. So I'm going to type in clear and enter. And we're going to cd into shell lesson data writing. Cat to look at the haiku we're interested in for the tutorial. So haiku is some form of poetry, I believe. I'm not an expert on haikus, so please don't say please don't use my definition of a haiku. But that is the output from the haiku text.txt file. And we will introduce the grep command, which stands for global regular expression, print, but it's very much used as a verb by bash programmers and Unix programmers. It's the same way you would say Google this, Google that. Grep's very much used in verb form. So we're going to grep not from haiku.txt. And what is the output there? So obviously we can see previously that with cat, there's about 9 lines worth of text with 2 empty lines in the original file. When we use grep not for haiku.txt, that's being filtered down to 3 lines. Why is that? We have requested not, the string not, from our data. So it's only pulling out lines that contain not from the original file. This actually was really useful for me when I was building and adapting the training module for this web page. I had to grep to find where I could change the title name here. But anyway, that's getting a bit away from the training. I'll get back onto the training. My apologies. So grep the from haiku.txt. If we look here now, we can see that as opposed where we had clean spaces between our knots, we've actually got an example where the is not its own unique word. It's forming a part of the word thesis here, whereas we're getting the actual word the here, we're getting thesis on the second line. And that's just the way grep works when you don't specify an argument between. So if we go to man, or if you can't use man, you'd do the help. But for my Mac, we'll go to man, grep, and we can see all the different command options here. The one we're interested in is W, so word regular expression. The expression is search for as a word. So I'm going to Shift ZZ out of there. And if I use the W for haiku.txt, comma. Now we only get where it's actually its individual unique word, not the sort of concatenated version with thesis, the with SEIS. So I hope that's clear. Sort of specify a word boundary. You want the exact word match using grep. We can do the same for multiple words together. So for example, is not .txt, say it's not working. We will see what happens when we don't use the inverted commas. And we will see why it's important to specify when we're talking multiple words on the exact word match, to use the commas to encapsulate is not, versus if we just specify it as is, it's going to capture just is by itself. Is it does capture the is not, but we're looking for the exact match here where it's exactly the data we're after. So this might be useful when you have a category of interest from your data set that contains multiple words, so blue pigeons or green apples or what have you. Grep n. So n, this is going to give us the line number, I believe, from the file. So we will do haiku.txt. So it should give us the line number, and we can confirm that by checking with cat. So I'll grep n it, the fifth line, 1, 2, 3, 4, 5. So that looks like it matches up. 9, yesterday it worked, and 10 today it works. So that looks like they've matched up. So grep n gives us the line number or row number where a certain data point we're looking, which can be useful if we're working with, say, 30,000 rows, and we want to find out what row contains a certain piece of data. So maybe we can remove that row by specifying the row number or something like that. We can combine arguments with grep, so we get the line number and the word boundary, the unique word, exact match. To get the line number, and we're making sure that it's the by itself and not thesis or therefore and so on and so forth. An interesting argument with grep is the v argument, which should be invert, which should give us the opposite of what we're so displaying the words that do not contain the. So this one, this the here has got the capital T. So this one specifically referring to the exact match with the lowercase t he. So it's going to show all lines, all words that do not contain the exact match of the word. So this could be useful if you're trying to exclude a certain class type. Maybe you have the class unknown in your data set in a row. and you're trying to remove that from the data, you can use grep to basically say grep nwv unknown haiku text, and maybe save that to new data or processed data.txt. So now you've removed a class that you're not interested in, some way of cleaning your data before you go into machine learning or statistical learning or deep learning or an area of analytics for your project. Grep R, so recursive option. And here we're specifying files in the directory. So if we look here, we've got the data directory, the thesis directory, and the tools directory, and the haiku txt file. So grep R recursively search files and subdirectories in our current directory. So our current directory, subdirectories for yesterday. And we can see the path of the file or files is specified here, and all the lines containing yesterday are also specified. And we've been over man and help for grep. There is another useful one which I'll introduce, but it's also included at the end of this section, at the end of section 7, called TLDR. Don't worry about this working in your terminal. It probably won't work unless you have it installed, which you would have to do separately. It's very unlikely to be built into your computer. So if this doesn't work, please do not stress. So this is what man for the grep looked like before, but we'll see a much more concise and simplified version. I find it a bit more practical. So TLDR stands for too long didn't read. And basically it'll show us the most frequent users of grep or any command that we're interested in. And also a little description and an example of the syntax. So grep, search pattern, path to file, and it'll tell us this is how you search for. So it's a bit, to me, it's a bit easier to read than man, especially I think for some of the younger generation. Going through man can be a bit time consuming, and we are interested in what is practical and gets us from A to B sometimes. I'm going to clear that. Okay, so now we're going to look a little bit at wildcards. So we're up to this point in the section 7 finding things tutorial. So we're going to go grep, or just make sure, yep, we're in the right directory, writing grep e, type in o haiku.txt. So what we're looking for here was E is allowing us to essentially facilitate a more extended variety of regular expressions, which Edric covers more extensively in the intermediate Unix shell course that is currently going on right now, but there'll be a recorded version of. So if you want some more insights into regular expressions, I believe Edric is covering that, and you can jump to that part of the video in the section. Perhaps even we'll ask him at what point in time he covers regular expressions. But for the purposes of this training, the sort of roof of a house, I'm not sure what this symbol is called exactly, but this basically specifies at the start of a line. So at the start of a line, we want a character followed by an O. So we can see that evidence-based by our output here. We're getting a search pattern where it's producing all lines where the second letter is an O in the text file haiku.txt. So start line, start of line, any type of character, the dot specifies we're not interested, and that's a regular expression. And followed by the letter, the alphabetical letter O. So that is how grep E works with regular expressions like that. Might be difficult to see how that can be useful in your project. But if you find that you need a really sophisticated way of searching for certain data in a large data file, this is definitely one of the best points. So it's really good to introduce it to you now so you can come back to this, refer to the notes from the tutorial or from the video and potentially use that in the future. Especially potentially if you're involved with NLP tasks or any text-based, whether it's a classification and you have textual data that you're trying to classify, then you may find yourself needing to look for or use regular expressions. All right, we've only got a few minutes left, so I'm briefly going to introduce SED. We'll do the TLDR version of SED and the man version of SED. So we go man SED stream editor. This is basically a command that's really powerful for replacing data, substituting data, inserting data, and even removing data quickly. So we can TLDR SED as well and see the most common use of SED is to substitute data. So you find that you specify a pattern here, you specify what you want to replace it with, and you specify a file or group of files that you want to apply that change to. And there are a variety of different applications of SED. So I'm just going to clear the screen here. We will make sure, I believe, Melissa, are there any questions in the chat? Caleb, yes, so the sort of rooftop symbol specifies the start of a line, the dot specifies the first character of a line, and it can be anything, and then the O is the alphabetical letter that comes in the second character position of a line in a file. Okay, so we're going to go back to, oh, sorry, I apologize. We need to be in this directory here. So I think if we type in that cd dash, it'll take us to the most recent directory we were in before we made a mistake. So this could be anything. And this will take us to what directory we were in before we entered this command using that. So now we're in the directory of interest. We're interested in this notes.txt file here. So I'm going to type in sed, specify the S here for substitution. Maybe it'll be good to see what's in the file first for everybody. So we've got a to-do list, basically, somebody's to-do list is their notes, finish experiments, write thesis, get postdoc position, preferably with Dr. Horrible. So we're going to substitute something we don't like in the data. Could be a null value, could be an erroneous value, it could be a large number. It could be a variety of things. It could be we just want to change the class name, for example. So we're going to change horrible from Dr. Horrible to Dr. Nicest Person Ever. File notes.txt, and we'll see that we can quickly apply the change. This gets really useful across large data sets where you don't want to keep repeating the same change over and over, and you want to apply it at scale. And you can create a processed, so I'll just type up so that we get the same command we entered previously. You might want to create a processed data file, for example. On the Mac, to sort of clear my terminal really quickly, I can do Control U. I'm not sure if that'll work. I don't believe that'll work on Windows, but the Windows equivalent would work as well. If you have a really long mistake typed in and you just want to quickly remove it, I know Control U works on Mac. It is 2:30 now. We covered most of what I wanted to cover. We didn't get to find. We didn't get to find in the find command in the section 7. But we did cover grep. We introduced sed. we introduced too long didn't read. If you want to learn more about too long didn't read and use that instead of man, follow this link at the bottom here. Installation instructions are there. And I think we won't take up any more of your time because we've hit the allotted, it's 2:30 now. So thanks everyone for attending. Melissa, do you have anything to add?
No, I think that's it from my side as well. Sorry, I was just busy with the chat.
All right.
Yeah, I think it might have seemed a bit like overwhelming maybe with all the commands.
Yes.
But I think it might be really good if you maybe go through the GitHub thing, which you shared the link for in your own time.
Mm-hmm.
And then you might recall things that we explained during the session, or you might even have a look at the recording again at a specific part.
Yes. Yes. And for everybody, when you, if this is the first time you're using the command line, it is very intimidating the first week or so, but once you get through that first week and you've used it a couple of times in your project and got actual outputs and you're not just working with tutorial files, you will not feel that intimidation anymore. You will actually really enjoy it. So just be patient with yourself and don't overthink it too much, because this can be a really powerful tool for you once you get over that small initial challenge.
Yeah, and I think in general, when you start working, you usually do a specific task. And I personally, when I work on a project, I end up with working maybe with like 10 commands mainly, and then you keep using the same 10 commands and you start developing a routine for them because you always do similar things on your project. So yeah, I think you'll establish your commands at some point and get used to them. And even if you have any questions about Linux commands, or you want to do something in Linux and you don't know how, you can always feel free to reach out to us during your internship as well. And obviously also now, like, I think we're both happy to hang around a bit if you have any more questions after this session.
Yes, that's a great point. If you'd like to hang on to the Zoom call and you have questions, or you want to go over specific parts of the tutorial, just hang back and we'll be happy to help you out.
Yeah. So any more questions before we stop the recording? So they are recording and everyone can watch them. Or was everyone able to follow? Maybe a last thumbs up. I just think, yeah, I can imagine it's a lot to take in. It's like lunch and dinner together.
I remember my first session with the terminal, and I was, yeah, it was very intimidating for me the first time we did it. Thank you for attending.
Yeah, thank you. Right, let's stop the recording and let's hang around for any more private questions.
Yes, we will hang around for a bit.
Yeah.
Thank you.
And otherwise, see you guys in the other sessions in the next days.
Perfect. Thank you.
I think you have to stop the recording.